In today's topic, we're going to cover nuclear decay. I'll go over exactly what decay is, the equations that follow, and what to expect in future questions. Nuclear decay, as referred to in your book, is based off of radioactivity. What that is the disintegration or decay of an unstable nucleus. There are multiple emissions that each radioactive particle can complete, each with resulting different particles. The three different radioactive decays that we will be going over are the alpha decays, the beta decays, which are both plus and minus, and the gamma decays. Now, we won't be touching upon gamma decay as much as the other forms. This is because alpha and beta are much more important in regards to the questions that you'll encounter. This is just a general representation of what the emission process looks like. The particle emitted here is more geared towards alpha and beta emissions than it is gamma, but again, we won't touch upon gamma too much. The energy here is normally what's being calculated in your problems, and now I'm going to introduce you to the equations that you'll be working with to actually help calculate that energy. Our first equation is an equation you've known since you were but a child, E equals mc squared. This equation will help us calculate the amount of energy released after a certain decaying reaction for masses in kilograms. For atomic mass units, presented by the U, we can have their energy calculated by this conversion from atomic mass unit to mega electron volts over the speed of light squared. Once you see these equations in action, you'll be able to understand better as to how exactly we can calculate energy. Before you go into the actual problems, there are a few things that we need to recognize. If you go back into your chemistry days, you may remember this as the nuclear symbol. When developing our equations, it's imperative that you understand what each piece represents, so I'll give a quick crash course. The X here is the main element symbol. For example, C is carbon. The mass number A is on top of the element symbol, comprised of both protons and neutrons. The Z is the actual atomic number, which is the number of protons given in the element. Most of these will change when creating the governing equations, so it's important to recognize these kinds of changes. This is a table of values when we begin to encounter problems regarding mass defects after the emission process is complete. The problems may already provide these for you. If not, refer back to this chart. First, we'll cover alpha decay. The concept behind this is how the radioactive atom splits into two, the daughter nucleus and the alpha particle. In order to start this process, you have to take the mass number, represented by the A, and subtract 4 to get the daughter nucleus. The same applies to the atomic number, but you only subtract 2 instead. We not only receive the new particle from subtraction, but we also receive the helium atom from what was emitted during the process. This is always occurring within the lesson. All of this information follows this equation, with the helium atom appearing as the alpha particle. This is an example of the noble gas, radon. After completing the alpha decay, the atom emits the daughter particle, polonium, and the alpha particle, helium. Notice that the polonium atom has 4 less in mass and 2 less in the atomic number, which is given to the newly formed helium atom. Beta decay is a little different in terms of the process. First, we'll cover beta negative, or beta minus. In this type of emission, a neutron will transform into a proton and an electron when the neutron to proton ratio is too large. The electron that is created is left from the nucleus in order to help maintain the net charge that was originally in place. This is the general equation that you will govern most of your problems off of. The mass number doesn't change, but recognize that the atomic number increases by 1, giving a brand new element. This is an example of the carbon atom going through the emission process. It has become a nitrogen atom after gaining another proton. The main point that I want you to derive from this equation is that the atomic number is increased by 1 in the beta minus process. Beta plus is a similar process in terms of the equation, but not so much in terms of what's caused the emission to occur. In this decay, the proton turns into a neutron and a positron. A positron is just like an electron, but has a charge of +1 rather than a charge of -1. The equation here is to show you how the structure of the decay is. Instead of adding 1, you subtract 1 from the atomic number. Also, the beta symbol you see here can also be written as e to the +1. This is another example to help demonstrate this process. You can see the oxygen atom going through beta plus decay and how it loses 1 proton and now becomes the nitrogen atom, with a positron released. Now, there are 2 small topics I will discuss, but I won't discuss these as much because you won't run into these problems in class unless time permits. Gamma rays are a simple concept to comprehend. Instead of the particles performing the action, the nucleus does, in which it releases energy without the loss of particles. The equation for this is simple because the same atom is on both sides of the equation with no changes occurring, but the product side has a gamma ray added to it, which is a form of energy being released. That said, there really is nothing much else to talk about in terms of the gamma decay. The last and final topic to address is the neutrino. This is emitted only from beta decays to help follow with the laws of conservation such as energy and momentum. This is a chargeless particle and its existence was previously doubted but later proven. It's represented by the letter V in the equation, but it's very unlikely that you'll encounter this in future problems. And with all that said, we have covered everything within this lesson. If you decide upon further help, especially in regards to concepts, you may refer to the simulations video. Following that is the problem solving video detailing how exactly you'll solve these problems when you encounter them.